Okay, so area of a triangle. Still has a base and still has a height. Okay, but again, if you think back to the rectangle, which generally that's the one that everybody knows. Okay, if I were to cut that rectangle in half, I get two triangles, yes? Are they congruent? They are, because these are congruent, those are congruent, and the diagonal's congruent to itself. So I have two congruent triangles. So if the area of my rectangle is base times height, then the area of my triangle is 1/2 of the base times the height, right? That's the area for any triangle, because any triangle is just simply that. It's half of a parallelogram. Okay? So your area for your triangle, you can write it either way, I don't mind, whichever you choose, is 1/2 of the area of a rectangle or parallelogram. Or if you prefer, some people like base times height over 2. It's the same thing. Okay? Keep in mind, you might have triangles that don't look like this. They are obtuse. You still have a base. You still have a height. The height might have to be outside or on the triangle. So let's say this is 6.4 feet. And let's say our base is 10 feet. And sometimes they'll give you even this little dotted line here. What do you suppose people would do wrong with this? What do you think the mistake people would make here would be? They also include the 4. You don't need the 4. We need a base and a height. The base and the height, the base has to be a side of your triangle, and the height has to be perpendicular between the base and the vertex of the triangle. So if we do area is 1/2 base times height, or base times height over 2, whichever you like. Area is 1/2 10 times 6.4. So it'd be half of 64, or 64 divided by 2 if you're using that. So area would be 32 square feet. All right. 2 last examples, or an example and just a clue on one of your homework problems. Okay, there's one of your Pythagorean triples. We'll do the base times height divided by 2 this time. You have 3 dimensions. Which ones are a base and a height? 5 and 12. They're perpendicular. That makes it easy when you're looking for those perpendicular lines. So area would be 5 times 12 over 2, which is 60 over 2, which is 30, and let's call these centimeters. So that would be square centimeters. That's not trigonometry. You'll be using trigonometry, though, when we do areas of polygons. But that's a couple sections away. Okay. This one I'm not going to finish for you, but I'm going to get you started so you don't get there and not know what you're supposed to do. So 30 and 32 you have coordinates. Okay. The good news is you might be looking at this and thinking, oh no, we have to use the distance formula. You don't have to use the distance formula. As long as you can get a base and a height measurement from your plotting of the points, you're fine. When you plot these out, if you get something that is not directly horizontal or directly vertical, okay, remember, you're going to be able to get one measurement between two of the bases, okay, as a height. Some of these, I'm not doing this one specifically, but you're going to have to plot these and find a base and height. So say I get something like this, all right? I believe you're able to get a perpendicular by extending it on the outside. So you'll be able to use the measurements of, I mean, one of these I think is vertical. Okay. But you might have to do your height outside. Extend it. All right. So you're going to plot them, find a base, find a height, plug in the formula. Okay? All right, homework. I haven't sent you the objective sheet, but I'll probably be able to do that by the end of the day. The homework is on the board. It's 1 through 9 odd, 10, 17 through 23, and 30 to 36 evens.